Hello everyone, this is Ms. Ortega, and in this video we will learn about atoms, atomic structure, how to solve for the atomic number, and atomic mass. Atoms are the basic units of matter. Let me show you. Plants and flowers are made up of atoms. The liquids that you drink, such as this water, is made up of atoms. This apple is also made up of atoms. You and I are made up of atoms. My cameraman is made up of atoms.
Am I?
Yes, you are. Basically, everything is made up of atoms. Atoms are made up of three particles. Protons, which have a positive charge, electrons, which have a negative charge, and neutrons, which have a neutral charge. These three particles are also composed of even smaller particles called quarks. Let's take a look at an atomic structure to see where these particles are located in an atom. This atomic structure is not exactly the way atoms are, but it is the best representation we have to better understand protons, neutrons, and electrons. In the center of the atom, the nucleus is located. In the nucleus are the protons and neutrons. Outside of the nucleus are the electron shells, and that's where the electrons are located. The world is diverse, and so are atoms. There are different types of atoms. The element of oxygen is different than the element of helium. You might ask, how and why are they different? They differ because different elements have different numbers of protons, neutrons, and electrons. The atomic number is determined by the number of protons an atom has. Think about the number of protons as an ID number. Let's say you have an atom that has 6 protons, therefore atomic number also has to be 6. If you look at the periodic table, the only element that has an atomic number of 6 is carbon. To better understand this, let's take a look at the nuclear notation or chemical symbol setup of an atom. X is a chemical symbol for the element. Every element has a chemical symbol. For example, C is a chemical symbol for carbon, or O is a chemical symbol for oxygen. A is for the mass number. The mass number is the sum of protons plus neutrons. Z is the atomic number, or the number of protons, as mentioned before. The nuclear notation is going to be very different from the setup found in the periodic table. We already went over the nuclear notation. Now let's take a look at the setup for the periodic table. The atomic number is always going to be at the top. We will find the chemical symbol in the middle, and then at the bottom we will find the atomic mass. The atomic mass is also the number of protons and the number of neutrons of an atom. However, the main difference between the mass number and the atomic mass is that the atomic mass is the average of all the different types of isotopes of that element. Isotopes will be discussed in a different video. Let's do some practice problems to become more familiar and comfortable with solving the atomic number, atomic mass, number of protons, neutrons, and electrons. Before we start, I want to recap how to solve for these components. The atomic number is equal to the number of protons. The atomic number is also equal to the number of electrons only if you're dealing with an atom that has a neutral charge. To solve for neutrons, you have to subtract the atomic mass minus the number of protons. So let's get started. Fill in the table below for nitrogen. So we're going to have our handy dandy periodic table next to us. We know that our atomic number is located at the top, therefore it's 7. The atomic mass is 14.0067, but we're going to round to 14. The number of protons is also 7 because atomic number is equal to the number of protons. The number of electrons is also 7 because we're dealing with a neutral atom. And our number of neutrons is 7. Since the atomic mass is 14 and the number of protons is 7, 14 minus 7 is 7, so our number of neutrons is also 7. Let's do another one. Fill in the table below for calcium with a charge of positive 2. The atomic number is 20. By looking at the periodic table, we can easily solve that. The atomic mass is 40.078, but we have to round to 40. The number of protons is also 20 because the atomic number is 20, so it has to be 20. The number of electrons. Since calcium with a charge of +2 is not a neutral number, we have to do something different. We have to solve for the number of electrons. To solve for the number of electrons, we have to subtract the atomic number minus the charge. In this case, the atomic number is 20 and the charge is +2. So 20 minus +2 is going to be 18. Therefore, the number of electrons for calcium is 18. To solve for a number of neutrons, we have to subtract our atomic mass minus the number of protons. Therefore, we have to subtract 40 minus 20, and our number of neutrons is going to be 20. Now do a problem yourself. Fill in the table below for oxygen. Feel free to pause the video, go over the lecture again, or take a look again at the practice problems we have just done. After about 10 seconds, the answer to this question should come up. I hope you got the right answer to the problem, equal to the number of protons. The atomic number is also equal to the number of electrons, but only if you're dealing with them. To solve for atomic mass, we have to add protons and neutrons. And to solve for the neutrons, and to solve for the number of neutrons minus atomic number or number of protons.